Good morning, year 10s. Thanks for coming, guys. Right, so I've suddenly realized I need to put my YouTube channel on the other screen. I need to pop out the chat. Right, so I've suddenly realized. There we go. Sorry, going to that now. Oh, I hope it's broadcasting at decent quality. Mine appears not to be. Who's first in? Jack was first! Woo! He made it. He actually did it. That's amazing. Right. Let's get rid of that now that I know it's working. There's my chat. I like it. Right, let's share screen today, guys. Let's crack on. Share screen. And that one. Well done, Jack. Good man. Right, okay, so today's lesson, guys, bonding lesson 10, covalent. Woo! We're finally getting there. We're on the home stretch now, guys. So we've finished metallic, we've done ionic, and now we're moving into our last family of covalent. So the first thing we need to do, our learning objectives is number 1, understand covalent bonds. Number 2, know the 2 types of covalent structures, know your giants, and explain properties. So first things first, covalent. So we need to understand what a covalent bond is and when it occurs. So covalent bonds. So number 1. Bullet point number 1. These bonds occur between 2 non-metals. Okay, so for example, it's always good to discuss and add examples to these various things. So, for example, which I'll do in purple, e.g. So, if we have sodium chloride, we know that this here is a metal because it's on the left-hand side of the table, and we know that this is a non-metal. So this, of course, we now know from our previous lessons that as a result of this, it's going to be ionic. They exchange electrons. The sodium will give its electron to the chlorine, and they will form ions together. They will form their ions. There we go. Yeah, and they become this. And then sodium chloride. We've now got chloride rather than chlorine. It's gained that electron. So this is ionic. Yeah. Now, the difference is now that if you take in this circumstance, why do they exchange? They exchange because the metals want to. Sorry, I'm late. There's Henry. So we know that the reason why this occurs is because the metal wants to get rid of its electrons to have a full outer energy level, whereas the non-metal wants to gain. But however, if we now have 2 non-metals like chlorine, so chlorine travels around in pairs, and the question is why? And the reason being is they both want electrons. So what they're going to do is they're going to share. That's what they're going to do. So rather than a full exchange, what they will physically do is overlap. Their shells literally link together, and they will share electrons in the gap. So this here is a shared pair of electrons. Shared pair of electrons. Notice that I've drawn it dot and cross. This is called a Lewis dot and cross diagram. A Lewis dot and cross, just like we had with the ionic, but now we have it with covalent. So they're sharing electrons. So you can see this all over the place. If we look at another example, hydrogen, all the diatomics. We know that hydrogen travels around as a pair. Well, the question is why? The reason being is each hydrogen atom has 1 electron in its outer shell. And what they're going to do, we know that the first shell only holds 2. But what they're going to do is they're going to share them, 2 nonmetals. They're going to link together, and they are going to share their electrons in the gap. And this now gives each of them 2 electrons. They're both happy. Up at the top here, they only have 1 each. They only have 1 each here, 1 each. But then once they share, they both have 2. And this means their outer energy levels are full and therefore stable. So we realize now, so what we now need to do is a really important note. So this is, I'm going to do in red, guys. This is a nota bene. Nota bene. This is an exam question. So, nota bene. Explain what a covalent bond is. Question. It's actually just explained, so it's a full stop. So the answer to this question, so answer, bullet point number 1, a covalent bond is a shared pair of electrons. Between 2 nonmetals. Bullet point number 1. Bullet point number 2. So what does this look like? Looks like this. Yeah. Bullet point number 2. There is an electrostatic attraction between the 2 nucleuses, 2 nuclei if you prefer, the 2 nuclei and the shared pair of electrons. And we're done. So can I just say, by the way, this question here is 3 marks. Covalent bond is a shared pair of electrons between two nonmetals. The electrostatic attraction, it's actually more than that, between the 2 nuclei and the shared pair. It's actually 5 marks. Now, can I just emphasize one bit though? So this bit here is the most important. Most important. It's where this is always on the exams, and it is really important for me to highlight that bit. Just to explain that I don't have any of these words in my head. I just have 2 images, 2 pictures. I have this picture here at the top, pick one. I also have this picture. That's the other picture I have in my head. And that there is the electrostatic attraction. So these are the nuclei. I can even label it fully. I don't like labeling that with green because we've used green for the force. Yeah, that's the electrostatic. That's the nuclei. This is the image I have in my head. I don't really remember anything. And that there is the shared pair of electrons. Don't really like doing that. Makes it messy. Shared E minus. There we go. That picture is what I have in my head. By the way, if you actually draw that, you get all 3 marks. Just so you know, that diagram there gets you all 3 marks in that exam. This bit here is the most important. I really do need to flag that. This bit here, you really ought to write. I never write down that without the top bit, though, just so you know. I just know it's shared pair of electrons between 2 nonmetals. But that there is the most important bit. Right. Okay. So we can now do all kinds of funky stuff with this, with these dot and cross diagrams, and I can get you guys to have a go. So, oh, I also want to do another thing as well. Sorry, hang on a sec. Right, next. Covalent bonds. If I done something funky with my notes here, I'm getting bigger and bigger, and I don't really want to. So, make my pen a bit thicker. Oh, I see I'm getting really big. Covalent bonds. Covalent bond diagrams. So, number one, we've got our Lewis dot and cross. Yeah, Lewis dot and cross. But then we've also got a stick diagram. A stick diagram, which is this. X covalently bonded to Y. That stick there represents, don't know why I made it so long. Yeah, represents a covalent bond. You're going to see this in action in a minute. Okay. Next, bond rules. Bond rules. Okay. And the great thing is there aren't many, so don't worry, guys. So, rule number one. Number one, carbon makes 4 bonds. Number two, oxygen makes 2 bonds. Number three, hydrogen makes 1 bond. Number four, nitrogen makes 3 bonds. And number 5, all group 7. Group halogens, you know the name. Halogens, brackets, group 7, make 1 bond. Now, at this point, everyone's like, oh my God, there's so many bond rules. And I'm like, no, not really, guys, because you can predict all of this with the periodic table. So I'll show you why. So, why? Question mark? So, we know that a single covalent bond, 1 covalent bond is 1 shared pair of electrons. So that there is the same as this here. It's the same picture. So for every stick, you have a dot and the cross. You don't ever show that in that picture because that'd be like blending Lewis and stick, but it's nice to understand it. So what that means is if X made 2, X has got an overlap. If X made 2 bonds to oxygen, let's say we did that, what would the diagram look like? It would look like this. X and O overlap, and I have a dot and cross for that stick, and a dot and cross for that stick. There we go. I don't really like the whole shells being there, to be fair, because I'm not finishing it off yet. I just want you to see what a double bond looks like. So the question now is, so why does oxygen form 2 bonds? let's actually run all the way through. Let's do carbon first. So the question now is carbon, 4 bonds, question mark. Let's have a look at what carbon looks like. We go to our beautiful, beautiful, gorgeous periodic table. Oh, it's so beautiful. And we find carbon. And carbon has 4 electrons in its outer shell. 1, I don't like that there's that. I'm going to try again. Oh, I can actually do this. I can cheat. Oh, blimey. Ink to shape. Here we go. You guys are like, whoa. So carbon, thanks to us understanding our periodic table, carbon has 4 electrons in its outer shell. Well, it makes total sense that it's going to make 4 bonds. Because if it makes 4 bonds, it will gain 4 electrons. Because each covalent bond sees the gain of an electron. So it becomes like that. There we go. Makes total sense for it to make 4 bonds. That's what I've now drawn. So Lewis got across a perfect circle. How? Jack, it's not my, it's my laptop does it. I've got a little thing called ink to shape, and I can draw shapes with it. Look, I can draw a square and everything, and it'll, oh, it didn't actually work. I'll teach me. No, it won't do it unless it's a single line, I think. There we go. It's got to join together. Lol. So it makes sense for carbon to make 4 bonds. Let's look at the next guy. I then did oxygen. Let's have a look at oxygen. So why does oxygen make 2? So whoa, ink to shape these to turn off. Oxygen 2 bonds, question mark. Let's have a look at why. The reason being is oxygen in the periodic table has 6 electrons in its outer shell. That's the function of the groups. So we can go ink to shape. There's oxygen. And oxygen has 6 electrons. Let's draw its 6 electrons. There's its 6. It is going to make 2 bonds. So it gains 2 electrons. It's going to form 2 bonds. O, stick, stick. By the way, that is the same as O, stick, stick. That's exactly the same as that. Or O, stick, stick. Just to tell you, by the way, that in terms of a GCSE, you don't need to know the difference. Water actually, oxygen actually forms a bent bond. It doesn't actually do linear. It's actually bent, but you don't really need to worry about that at GCSE. They're all the same. Yeah, it doesn't matter. So just an example of this, you know, water, you'd never write water down like that. You could do at GCSE, they won't care. But actually, it actually has a shape, and water is said to be bent. And it has a bond angle of 104.5 degrees. Not that you need to know that's A-level. But it's a really nice thing to recognize. This is actually real. Now, carbon dioxide, on the other hand, right, now that we've drawn carbon and oxygen, let's do something really cool. So carbon makes 4 bonds, and oxygen makes 2 bonds. So carbon dioxide, CO2, what is my laptop doing? A pen might be dying. CO2, question mark? So the best way to do a dot and cross diagram is, oh, how many bonds a metal can have? 8? I'm not. Wait, I'm sure maths. No, Jack. Metals won't. Oh, how many bonds a non-metal can have? 8. No, Jack. Oh no, I can't answer that question, Jack. At GCSE 4. GCSE 4, Jack. Oh no, I don't like saying that. So in order for this to work, I'm going to have carbon at the center. I'm going to have oxygens on either side, and I'm going to form 2 bonds to each of them. And that works. I've got carbon here, Yeah, carbon, 1, 2, 3, 4 bonds. Carbon's happy. Yeah, oxygen, 1, 2. Oxygen's happy. Yeah, and then this oxygen also has 2. Yeah, so that's what. So now we can create a dot and cross from this. So what I now do to turn that stick into a dot and cross, all I draw are the overlapping shells. There we go. And then in the gap, I put 2 pairs. Now what you'll notice is carbon now has 8 electrons. Carbon has, everyone's trying to get to 8, remember, but oxygen doesn't. What we need to do is we need to put on her original electrons. So it had originally 6. If you want me to color code this, here were oxygen's original electrons. It had 6. Yeah, and then it's gaining 2 crosses from carbon to get to 8. Now it has 8. You've got to remember to add in the extra electrons. This is the same to that. What the rule is, make everyone add up to 8. That's all you really do for dot and cross, except for hydrogen, which is full at 1. So carbon dioxide is really cool because it's a double bond. Check this out. You're going to love this. What about nitrogen? So nitrogen travels around in a pair. So hang on a minute. How many bonds did nitrogen make? Nitrogen makes 3 bonds. Why? Because nitrogen has 5 electrons originally. How do I know that? Because it's in group 5. So it's going to make 3 covalent bonds. There you go. It's going to make 3 to fill and get to 8. Yeah? Turn it into a stick. Totally fine. There you go. But how would it do it to itself? So what about N2? Well, it's going to do it to itself. 1, 2, 3. It's going to form 3 bonds with itself. How is it going to do it? Right, so 1 pair, 2 pairs, 3 pairs. There's 6 electrons in there originally. Let's color code this. So I'm going to color code the nitrogens. Here's the red ones. It had 5 electrons originally. Right, let's do the other guy. Let's do the other guy's blue. Yeah, this guy here had 1, 2, 3, 4, 5. And now both have 8. A triple bond. Well done, Gayatri. It's a fun game, this. And it's not very difficult. And when you get to GCSE, the questions are really straightforward. They like carbon dioxide. That's come up a couple of times. But what they'll do is they will give you, GCSE is easy, really. Because what they're going to do is they're going to give you something like, they're going to say, here is ethanol. This is ethanol. And they're going to say, draw a Lewis dot and cross diagram for ethanol. And all you do is simply go, right, put circles around everyone. Hydrogen. Right. Carbon. Hydrogen. Hydrogen. Carbon. Hydrogen. Hydrogen. Oxygen. Hydrogen. Right. Now I've put circles around everyone. Now the great thing is all of the sticks in this picture are single bonds. All of them are, which means I just have to do this. Dot, cross, 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 dot, cross. Now make everyone add up to 8 except hydrogen, because hydrogen only needs 2. Could you have a carbon bonded with 1 nitrogen and 2 hydrogens? No, because nitrogen wouldn't have enough. Oh, one nitrogen, one hydrogen. Blimey. Yes, it's called hydrogen cyanide. Jack, that's awesome. Yes, that's called hydrogen cyanide. We used that to kill the Jews. Oh, we didn't. Germany did. The Nazis did. Awful stuff. Really, really toxic. Yes, you can. And here's the picture. Yes. Yes, you can. You're done. Yes, absolutely. You can now. You can start building stuff, Jack. That's so cool. You just literally built hydrogen cyanide. That's hilarious. That's brilliant. There's one person in this picture who isn't happy. Who am I? Is that covalent? Yes, they're all non-metals. Of course they are, Jack. All non-metals, so it's covalent. Carbon, nitrogen, oxygen. They are all non-metals, so it's covalent. Yes. Who's not happy in the picture? Who do I have to add electrons to? Wonder how long it's going to take the chat to respond to that one. See if anyone's... Jack's not too far behind, I know that. No. Sorry, got it right. No. Carbon has 1, 2, 3, 4, 5, 6, 7, 8. It's happy. Carbon. Change my color. Nope. Change my color. Carbon. 1, 2, 3, 4, 5, 6, 7, 8. It's happy. Thank you, Masaru. Oxygen. Oxygen. Whoa. 1, 2, 3, 4. It's missing. I need 4 more electrons. We're done. I love the fact that Jack, build something else. Give me something else to build. That was awesome. I love that you just built hydrogen cyanide by just throwing them together by the bond numbers. It's really cool. Love it. Oh, great job. So we're just playing around with dot and cross here at the minute. I love the bond rules. Do you want to see something cool? So chloroform. Chloroform is CHCl3. Right? This is otherwise known as chloroform. I wonder if anyone knows what chloroform was used for. Chloroform. So carbon is at the center. It makes 4 bonds. Hydrogen makes only 1. And chlorine is a halogen. Only makes 1 as well. There's chloroform. So now I can turn that now into a dot and cross. Carbon. Whoop. I'm going to do it into shape. Carbon. Retracted, knock someone out. Gayatri, that's amazing. Yeah, you've seen it in the films. Yeah, it used to be used as an anesthetic. You're absolutely right. Yeah. So carbon, right? So hydrogen, chlorine, 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 dot cross, dot cross, dot cross, dot cross. Who's not happy? To unconscious someone? Oh, that's really funny. Who's not happy in the diagram? Who's not happy in the diagram? Sorry, I've lost it. I've lost lockdown fever. Who's unhappy? Ian's laughing at my laughing at my singing. You laughing at my singing, Ian? I'll have you know I have the voice of an angel. Nobody's going to contribute. Come on. Hydrogen is happy, only needs 2. happy hydrogen. Carbon. Oh, make it fatter. Carbon. Whoa, that's too fat. Bit like me. 1, 2, 3, 4, 5, 6, 7, 8. That's good. Chlorine, well done, Gayatri. The chlorines, however, 1, 2. It's missing 6 electrons, so now just put on the rest of her electrons. I'll put them on as circles. It wouldn't actually matter in an exam. They don't care what things you do as long as it's a dot and cross in the diagram. So all of them need 3 more pairs. Notice how I'm not distributing them. I'm putting them into pairs to make it easy to count. Yeah, is it chlorine? Yes, it was, Gayatri. Well done. So there's chloroform. Always fun. Like it. How are we doing for time? I realise my learning objectives are not getting covered here. So what we're actually doing here is I'm changing my learning objectives. Yeah, no, understand the covalent bond. Yeah, and then the next thing is be able to draw dot and cross. Dot and cross and draw stick diagrams. I like it. Looks like stide. I don't know what stide is, but anyway. Let's have another go. Let's try something else. I love the fact that Jack, commendation. That was outstanding that you made hydrogen cyanide from the bond numbers. I loved it. Right, guys, have a go at this one for me. Can everyone have a go? I want you to turn that into stick diagram, and then turn it into dot cross. Off you go. Pause the video and have a go. Yeah, pause the video and have a go. So realizing oxygen's in the middle. Oxygen makes 2 bonds, hydrogen makes 1. There we go. There's our stick. If you've drawn it in a straight line, that's fine. Yeah, now we're going to turn it into dot and cross. Oxygen, hydrogen, hydrogen. And in the gap, go 1, 2, 1, 2. And then oxygen needs its extra 4 to get to 8. And we're done. Give me a thumbs up on the chat if you've done it and if you got it right. Next, let's try another one. Oh, I've got Zina who's like, I've already done it. Should we make it harder for you, Zina? Should we make it harder? What about this? This is one you've got to know for Edexcel. This is called hydrogen peroxide. Off you go. Give me it as a stick. Give me it as a stick. And then give it to me, dot and cross. Off you go. Pause the video. Pause the video. Amazing. Much more challenging because you're like, got it. Well done, Jack. Much more challenging because you guys are like, oh, not seen this before. How is that possible? Guys, it is possible. Think about your sticks. The best way to always start off with any covalent structure is to think about the sticks. Stick first, then dot and cross. I wonder how many people are going to get this right. So I'll give you the real shape. It does this. But if you've drawn it in a straight line, totally fine. Yeah? Right. So now we can turn this into dot and cross. Hydrogen, oxygen, oxygen, hydrogen. I've lost my mind. My mind is mush. Right. Dot, cross, dot, cross. Oh, 2 bonds, it works. Dot, cross. Winner. But then you need oxygen to add up to 8. We're done. There we go. If you want to see the more accurate, because that is the correct, by the way, the bond angle there again is 104.5 if you're interested. You guys have to know hydrogen peroxide. You've got to know it. For Edexcel at GCSE, they love hydrogen peroxide. Okay, let's try this one then. What about oxygen? What about that one? Give me the stick. Give me the D and C. Dungeons and that was D&D. Oh no. And Dragons. Oh, have I already done option? I may have already done option. Oh, let's do another one. Let's go for fluorine. Stick. And D and C. Dart and crass. So, stick. Oxygen's got to have 2 bonds. Winner. Dot and cross. Dot and cross. Dot and cross. And then you've got to make sure oxygen adds up to 8. Everybody must add up to 8 except for hydrogen. There we go. Give me a thumbs up if you got oxygen. Fluorine, F and F. There we go. 1 dot and cross in the gap, then everyone needs to add up to 8. I'm actually going to put the crosses on. Should have actually done the other option. They wouldn't care, by the way. They just wouldn't care in an exam. It doesn't matter. Yeah, but I'm doing it just for ease, so I know who they're coming from. But they wouldn't care in an exam. Just so you know. Oh man, I need to make this harder. Okay. All right. What about? Let's go for this guy. I'm trying to make it hard. You guys are making this too easy. Ammonia, nitrogen, NH3. Ammonia. Gotta love ammonia. Gotta love ammonia. Give that one a go. Give me the stick. And then give me the D and C. I'm loving this game. I'm having a right laugh. I'm having fun. Lads. I already did ammonia. Thanks, Aya. Oh, that's funny. Here's ammonia. So dot and cross. Man, Zyna, I need. Okay, Zyna. All right. I'm really tempted to really annoy you now. Really tempted. Take it if you got it. Can I just point out I didn't have ink to shape there, and that's like the perfect circle for that nitrogen. Nailed that. How good am I? Right. Off you go, Zyna. Off you go. Try that one out for size. Stick. D and C. Go on, Zyna. Impress me. Right, pause the video, Zyna. I don't want you to be having any cheating. No cheating. Oh God, Yorkshire. Stick, hello. So, tricky one, because carbon needs 4. Carbon got to have 4 bonds. So it's going to form a triple bond to another carbon. Look at that. Hello. It's called ethine, if anybody's interested. Called ethine. Damn. I can make this hard, designer. You really don't want me to. I got it right. Oh dear. Okay. Can I have a quick show of hands to see if everyone's feeling confident about this? So can I have, in fact, let's do a score out of 5. Everyone in the class, please. Give me a score. 1 is I have no idea what's going on. 5 means I feel like I'm really, I can do this. So give me a 1 to 5 on how you felt about the lesson so far. I love that. Calista, not really. Give me a 1 to 5, please. Masaru is solid. Jack 3.75. Calista a 3. Okay. Julius a 5. Zion is a 10. Gayatri is a 4. Okay. Naveen is a 4. Okay. Will more examples help? Do you want to have some more practice? Yeah. You can do more practice. It's easy. It just takes practice. The more you do it, the easier it gets. Okay, let's do some others then. Let's do can do anything really. Yes, please. Let's do turn this stick into dot and cross. It's much more GCSE, to be fair. Turn that. This is ethene. Turn that into D and C, into a dot and cross. So there's the next question. Then the next one, let's do try hydrogen. So there's that one. Then let's do hydrogen chloride. Turn this acid, this is HCl, this is hydrogen chloride in water, hydrochloric acid. Turn that into the stick. Don't forget to make everyone add up to 8 except give us the hardest one. Ugh. Stick, D and C. Do you really want Masaru? Right. So this is for Zaina and Masaru. Everyone else, please ignore it. Show me carbon monoxide. See you later, guys. So that's them dealt with. So hydrochloric acid, stick and then D and C. Right, then let's go for the next one. So I'll do this one for you now to give you the answer. I'll do it in red. So carbon, my little pen is hiccuping. And there's a double bond in the center. If there's a double bond, it means I need 2 dot and crosses in that gap, but everything else is one stick. This is very easy. Well, Masaru and Zaina, give me a shout when you've figured it out. HCl, stick, hydrogen makes 1 bond, chlorine makes 1 bond. Nice and easy. Overlap. Right, in the gap goes 1 pair, but chlorine needs to add up to 8. Yeah? Let's go for another one. Let's go for CO is easy. Oh, really? Oh, really, Zana? So, okay. Done with CO, I think. So they've all got 8. They've all got 8 electrons. How many bonds are between carbon and oxygen, Zina? I don't know what that means, Poetry. Yes, there are 3 lines. There are, you're right. It breaks carbon monoxide, breaks the bond rules. It breaks your bond rules, which is a nightmare. You do not need this for GCSE, folks. Just switch off. Yeah, just switch off at this point if you're not interested. So the point is they all need 8. So if we have carbon, carbon has 4 electrons in its outer shell, and it needs 8. Yeah, so what that means is it needs to gain 4 electrons. Would everyone agree with that? But oxygen, you know, we'll draw them separately and I'll put them together. Carbon and oxygen. Oxygen has 6 electrons. It needs to gain 2. Carbon has 4 electrons and needs to gain 4. Well, it makes sense. You always pick the one that needs the lower. So the oxygen needs 2 electrons. So it's going to form 2 standard bonds in the gap. So oxygen is now happy. Yeah, oxygen is now happy at this point. But carbon isn't. Carbon is still sitting there with only 6 electrons. So what oxygen will do is it will donate those into the gap as well. And it's a different type of bond. I shouldn't really have given it to you, to be fair. There you go. Stick. There you go. Top one's dated. Doing it with style. Anyway, that's A-level, by the way. An introduction to A-level dot cross. Guys, it's the end of the lesson. I will leave you here. I hope you found it all useful. I will set your homework of sticks to dot and crosses on the classroom. I will post that immediately since it's all ready to go. And I will see you guys. Oh, sorry, I'll stop sharing my screen. Whoa! I will see you guys all very soon. Have a nice rest of your evening. And I'll post the homework now. See you later, guys.